So, what should we start with?
34.
32.
I'm going to go with 14 first because they asked me about it, and I told them I would talk about it. I told them I would talk about it with everyone. Okay. 14. Strong sign. All right. We have a 90% confidence interval. And I was talking with this group as well that anytime you do anything with linear regression, it's always about the slope of the line. Always about the slope. Okay? Which of the following statements must be true if this is your interval? Now, I'll just be honest. The first thing I do when I see an interval like that is I ask myself, well, what is the statistic that they built that interval on? And that would be what we call B sub 1. Does anybody know what that is? What B sub 1 is? That's beta. It's called the slope. It's the slope of your data. All right, when you made your scatter plot, we don't have the scatter plot. But what's the middle number in between those two numbers?
0.
No, I don't think 0 is right in the middle of those two numbers.
0.8.
You'd have to add them up and divide by 2. Because it's not 1.3. They want you to think it's that. It's not. You got to divide that number by 2. What is it? Just use the calculator, man. Like 0.674. So this is slope. Now, even though that's not a very steep slope, right? A slope of less than 1 is very, very shallow. Be like that almost. Right? Remember slopes in algebra, right? If it was like slope of 10, it's very steep. Right, so the smaller the number is, the more shallow it is. Yes, because the slope of 0 is horizontal. No, I don't feel like everyone. Yeah, okay. So it's close to horizontal, but it is positive. If the slope of your scatter plot is positive, right? If I draw a scatter plot and it's positive, even though it looks like it's barely positive. All right. What do I also know about the correlation coefficient? It's also positive. That's why it's A. I'm not sure how I would know what the sum of the residuals are without them telling me anything. I don't know. A scatter plot of the data would show a linear pattern. Do I have any idea what the scatter plot looks like?
No.
I don't. And then they try to trick you with this. The D was trying to trick you because if you add these numbers together, you get that number. But you have to divide by 2 to get the slope. So if this would have said the slope of the sample regression line is 0.674, that would have been true. And then we know the slope isn't 0 because the slope has to be in the middle of your two numbers on your interval. Everybody good?
Yes.
That's a tricky one. Okay, let's go to the next one. Who's got another one? Which one? 32. Is that going? The very last one. Okay.
Oh, that.
The very last 32. I see. With Amber.
Amber Road.
The very last 32. Am I on the right one? Okay. So this is talking about a 95% confidence interval. Again, for the slope. So when I hear that, I'm thinking that I should be looking at the slope. In my table of values, what is the slope? What is the slope in this table? It is 2.697. So if I was making an interval, it would be B sub 1 plus or minus the margin of error. So 2.697 replaces B sub 1. Who knows what's going to replace margin of error?
Another error.
That is a part of it, standard error for the slope. Times, I think I heard Z star? Did you say T star? It's all right. T star with degrees of freedom. Why is it T? Because it's a linear regression T interval. When we're doing linear regression, you should be using the T distribution model. So on this test on Thursday, you've got the chi-squared distribution. You remember what chi-squared looks like? All right, well, I guess I'll draw that then. Kind of looks like where it's kind of skewed to the right. That's chi-squared. All right, that's the squared. And then for the T, looks normal. So should I see any Z's on the test on Thursday? No, shouldn't see any Z's. All right, don't worry, they're coming back. And then, okay, so it asks for the margin of error, doesn't it? The margin of error? Yes. So ultimately, I end up just caring about this. You'll notice the 2.697, although you should know what that is, that's the slope of your sample data. Ultimately, I don't need it for this problem. All right? So I was like, okay, let's see what can help me. When I look at the answer choices, what does it tell me T star is? So do I need to go into the calculator to do inverse T to find T star? No, Myra, because they've told me all the answer choices are the same. So doing that, I'll find that it's 2.28, but is that really going to help me? That's a waste of time. So really I need to figure out what is standard error for my slope. And if you look one more to the right, you'll find the standard error for your slope.
What is the 4.570?
This is for the constant. We do not run linear regression T intervals for the constant, only for the slope. Now, whoever asked this question, do you know what the most common wrong answer is? B is the most common wrong answer. Why do students put B? And what do you remember about the standard error formula? It's standard deviation over the square root of n. But guys, what's crazy about this, and if you're listening right now, this will help you on a previous problem in your packet. If they give you standard error, what have they already done? They've already calculated it for you. So you don't need to add another square root in the denominator. That'd be doing too much. Right? They've already done it. Say thank you and move on. Say, got that one right. It is A. I'm sorry if I didn't make that clear. That's why I went wrong next to B. It is A. Yes, is it not A? Did my key not say A? There might be multiple 32s. Make sure you're checking this is at the end of the packet. Marcelo, this is 2012, I believe. So make sure you check 2012, number 32. So the packet, if you're confused by that, starts at 2017 and works chronologically, like going backwards. So 2017, I think 2015, and so make sure. I know that my order on the key is not correct. I'm sorry. 34. This one? Okay. Barely fits. A little bit smaller. Okay. I think this question might be the perfect question to follow up what we just talked about. So it's as if you're ready to be a teacher. You should be a teacher. No, you don't want to be a teacher? What made you not want to be one? Being in school?
Money.
The money. You don't even know what it feels like. I have plenty of money. Right, you've seen my Tesla. Oh, don't worry, you will. I'm going to roll up May 28th, 6 in the morning. You guys are ready for Six Flags. Be like, suckers! No coach buses, nothing. It's an Accord. Okay, Luis?
No.
That doesn't make it okay to call someone a loser, George. All right. 34. Bless you. Let's do 34. Okay. This one is a little challenging here. Do you know how to find your test statistic? Let's try to do this generically. Generically? Because this will be on the formula sheet. It's going to say, I believe, statistic minus parameter over standard deviation. That's what it'll say, I believe, on the formula sheet, which is not very helpful if you don't know what you're doing. So if this is for a linear regression t-test, what is my statistic? Linear regression, I only care about what? The slope. What have I used for the slope when it's a statistic from data? B sub 1. That's my statistic. Minus, what's the parameter? Do you remember when we did the null hypothesis and the alternative hypothesis last week? What did I use? I used 0, so you could write 0, but I also used beta sub 1, which was 0. Over, I'm not going to write standard deviation. What am I going to write? The standard error of beta sub 1. Okay, now Nadia already told us that the big B, beta sub 1, is 0, so that's replaced with 0. What is B sub 1 equal to? What is our slope from our statistics here? Very good. You see how you look at exercise time, and it's negative 2.2 over
0.07.
Very good. And I believe if you set that up, you will see that the answer is D. And this goes right into what we just talked about. What is the most picked wrong answer? E, because students think, oh, I need to put it over the square root of n. But guys, they've already done that for you. The standard error is done. It's in the computer output.
Nice.
So what a perfect follow-up question. Thank you, Stephanie.
Nice.
Who's got another one? Man, if we keep going at this rate, we can get them all done. Who's got another one?
33.
33. Which direction? Back towards the beginning? Yes.
Second question.
That one? All right, right here. 33? Cool. Get away. There we go. All right. Ooh, blood sugar levels and brain shrinkage. That doesn't sound good.
No, it's not.
This is Marcelo. We're going to show you what to do here. If you're going to get this answer right without guessing, you will need an Inspire. You can still get it right. It'll just be a guess. All right, so here we go. We've got a confidence interval. A 98% confidence interval for a slope. So what is the slope?
0.161.
0.161. So immediately I can cross out A and B. Please ask if you don't know why I just crossed out A and B. So the slope, remember, I don't care about the constant. I don't care. So the slope is 0.161. The coefficient for blood sugar 0.161. Maybe this will help. The formula I would write is, let's see, what is it? Brain shrinkage? What do you think the other variable is called? Yes, shrinkage. Pat equals negative 15.668 plus 0.161 times sugar. So what I'm trying to do here is I'm trying to show you, I care about the slope. Right? This is the linear regression model. Right? With, remember, A plus BX, that's the y-intercept, that slope. That's all I care about is the slope. That's my statistic. So it goes slope plus or minus T star with your degrees of freedom times the standard error of your slope. Well, we also know the standard error. What is the standard error?
0.073.
Excellent. So what other ones can I cross out? None of them. Do you see how they're all the correct standard of error? That didn't help me eliminate any. We're on 33. So now it comes down to T star. This will separate the students that get it right or are guessing. How are we going to find T star? Excellent. Inverse T. What level of confidence are we using here? 98%. 98. So how much is in each tail? Not a lot. Just 1% in each one, right? So I'm going to use inverse t, and I'm going to use 0.01. Why did I pick that? Because that's the area to the left. What's the other one I could use? 0.99. George added 98 in 1 and got 0.99. Now the key thing is, do you know the degrees of freedom?
Oh, yeah, it's 21.
They gave you the sample size of 22, and the degrees of freedom is sample size minus 1.
So which test is the one that has a different degree of freedom?
The degrees of freedom for two sample t-tests, your calculator will tell you what it is. Okay? Chi-squared has a little interesting for degrees of freedom because there's 3 chi-squared tests. The first one we did, goodness to fit, was just the number of your categories minus 1. For the homogeneity and independence, you'll get a table, and it's rows minus 1 times columns minus 1. Every time. I think there's a question on that. So let's do that one. Okay, are we ready to go to the calculator? All right, we're using degrees of freedom is 21. All right, here we go. So calculator, you just do a calculate page, just letter A. Menu. Stats. Distributions is right. Inverse T, which is number 6. The area I told you I'm typing in 0.01. George, what's the one you could do? Not negative. 0.99. Should never be negative, right? Area is always positive. 0.99. And then degrees of freedom we said was 21. And hit OK. And it's 2.518. So my answer is going to be C. D might be. D. Sorry about that. Yes, everybody see why it's D? Did I mess up? I messed up? What did I do wrong?
Or maybe we just looked at it wrong.
What did you guys put into for T star? Like, did you do inverse T? Oh, you're looking at the key. Well, there's my key. Pull it up. You have it.
It says C, but I got D as well.
Isn't it C because the 98%?
Huh. It should be 0.01, right? Yeah. I mean, I would honestly say there's like no difference. I mean, minimal difference there.
So which?
You know the process? You know the process?
So which was the answer?
I mean, the answer is D. We just did it. The answer is D. So I probably made a mistake.
Everyone makes mistakes.
Thanks for that. Okay. Do you want to do that one, Nadia, where it's the degrees of freedom for chi-square? This one here, 32. Should we do 32? And it's about soccer, so the boys and maybe girls who are following the Champions League. Who are you going for? Yeah! Woo-hoo-hoo! Get an A on that test.
Me too.
Nice, is that? Can you name one Liverpool player?
Soccer.
Name one Liverpool player. Don't.
Can you hear? Yeah.
Pele. Jacob, you said Pele. Okay. So my first Shakira. That was amazing. Okay. It's close, right? One letter off.
Shakira.
But she said Shakira, so.
No, she said Shakira.
Oh, okay. What's his first name?
I don't know. Yeah.
Jordan. Okay. Where is he from? Ah, there you go. Somebody knows. How old is he?
32.
28.
Pretty sure he's younger than that.
Younger.
Yeah, he's younger than 29. I think. Check it out. Google GTS. Google that. I have a piece of glitter on my face? I got it? I get it? Still there?
Alright, Alyssa.
All done? Okay. Read 32. We're going to talk about 32. You can ask right there.
You said 7.
Because I wasn't
Not
here.
exactly.
I wasn't here those days.
You were here for that day.
No,
That was it was early on in the lessons. Like you weren't here for the very last one.
I wasn't here for the very first one and the very
I think that was the second one. Just do it's only a couple of points. Just do your best. Thanks, Alyssa. You can leave the desk.
Oh, wait. I have a question.
All right. So, do you see how this is a two-way table?
C.
So degrees of freedom is calculated as rows minus 1 times columns minus 1 for when you have a two-way table for chi-squared. All right? So how many rows do we have? Rows. 4 rows. How many columns? 2. So what's the degrees of freedom for this problem? Does everyone see why it's 3? 4 minus 1 is 3. 2 minus 1 is 1. 3 times 1 is 3. So it's not A. Okay? I think I heard a group over here say they liked B. Be careful about B. B says the chi-square test should not have been used because 2 of the counts on the table are less than 5. I don't care if the counts are less than 5. What do I care about with that 5 number? We already forgot. But what is more than 5? What is more than 5 in each cell? Because it's not more than 5 in each cell. But this is the actual amount. I care about the expected numbers. The expected numbers better be 5 or more. And if you use that matrix and found the expected numbers, they're more than 5.
Oh, that's
Do you want to see it? Yes? Do you want to see? Okay. All right, let's do it. Calculator. Menu. Let's enter the matrix. Matrix. Create a matrix. Matrix. I heard it was 4 rows and 2 columns. Yes? Okay. What were the numbers, George? Read them out. 182. 2. 18. 6. 15. 26. 3. And 10. What did you label it as? Or did you not? Yeah. Anyone? Did anyone do this? So you hit Control VAR, variables. Control, that's the store, and let's just put in letter A. I just put in letter A. What's wrong? Stephanie, just say it, you're good? What's wrong? Did you go to a matrix? Create a matrix? Menu, matrix? Hit Control. Control, variable. And then A. Okay. So why don't you guys just not do what I'm about to do so you can see what happens. All right, just watch. Menu. Stats. Stat tests. Where is it? I believe this is an independence test, but you'll notice it's homogeneity or independence is the same one. Two-way test. We have A as our observed matrix. Do you remember how to get the expected matrix? Hit variable, expected matrix. And look at that. What do you notice about all the expected numbers? Look at that.
There's one that's 5.6.
And, I wonder if that's more than 5.
It's
getting it close.
Yes, but close only counts in horseshoes or hand grenades.
It's saying 69.9. Are you still passing?
no.
Again, is that horseshoes or hand grenades?
No.
No.
All right, then. I rest my case.
Still pass.
All right. So, is B correct? No. But I bet a lot of you, maybe not a lot, I bet that some of you who are reading this question and knew what you were doing maybe thought about B because you saw that number 5. That's called the expected cell condition. I think I watched that. Something like that. Expected cell condition, where you need the number to be 5 or more. Okay, let's look at C. Oh, immediately I know C is wrong. Why do I know C is wrong?
There is an association.
The null hypothesis should always be that there is no association. That's why C is wrong. The null hypothesis should always be that there's no association. So C is wrong. Now we're down to D and E. P-value less than 0.001. That's really small. And it suggests there's an evidence of an association. I mean, that D sounds like exactly what we would conclude. So I think D is right. Let me check E out. I mean, I guess I could look at, this is a waste of time, but I could look at the computational matrix. Which one's the fans? The second row?
Yeah.
I mean, the second row is not really driving it. What's driving it? The first row. That's the players. All right, players going to play. So, the answer is D. Let's do one more. No, we're done. We should just be done.
Yes. Yes. Wait.
This is the first year somebody has
21.
said that to me.
21.
I think enough is enough.
Let's do 21.
21. Which direction? All right. 21. I don't think 21 actually required any knowledge about linear regression t-tests. This was just, do you know anything about linear regression? And the key thing, well, if you do not, then Thursday and 2 weeks from Thursday is going to be hard. But ultimately, after you run your linear regression,
You're supposed to see smile.
I'm almost there. We're so close. After you make your scatter plot and you decide that the scatter plot has a linear association, you're free to run your linear regression model. But before you use that model, you always check the residuals plot. And we're hoping to see what? No pattern. And when it says which one of these basically is appropriate to keep going forward for your linear regression t-test, the only one that would make sense would be C, because that one is the cloud. Why are E and D not good? I think we all agree why A and B are not good.
Because you can see a pattern.
Do you remember what this is called? When it kind of does that, like where this, like in E, it kind of goes shoo.
Outline.
It's called a fan. That's a fan shape. Because it looks like a fan. Yeah.
Alright.
Okay, we have time for one more. Let's do another one. The next one? Did we do that one? Oh man, this one, it was a coin toss here, because you knew it wasn't going to be A, B, or C, since this is about chi-squared or linear regression t-tests, and this question is only about chi-squared. So you had to decide, is this a goodness of fit, or is this a test for independence? And when I read the question, it says whether there is a relationship between vehicle type and color. Immediately that's screaming out, is there a relationship? Is independence? I told you this would be, you didn't believe me, but I told you this would be easier on the AP exam. Remember that Kahoot we did? And everyone was really excited until Michael got one wrong. Those were hard. I think this one was much easier. Ask for it. Let me stop.